Thanks, everybody. So my name is Markus Mayr. I'm Product Marketing Manager in the Microcontroller group with ST, responsible for our STM32 microcontrollers, which are using the Cortex Arm cores, mainly Cortex-M cores, and also recently we added products with the Cortex-A core. And I'm also responsible for our activities in the AI neural network field for our microcontrollers in the Americas. So we've already talked, and most of you know what is artificial intelligence, or machine learning. So it's used a lot already in our daily area. So it's used for face recognition, autonomous driving, stock market trading, handwriting recognition, and so on. So, and I think what we've heard before is also one of the main things. It's mainly done really in the cloud with a lot of processing power and a lot of traffic on the internet. And that's, I think, where we are coming in, and we heard before from my speaker before, to move some of those areas more to the edge. So besides artificial intelligence, machine learning, and deep learning, and I think deep learning is very important. And here's some examples which show why even deep learning is very important, even if you want to do it on the edge, because you're really increasing your accuracy by a big ratio if you use neural networks, deep convolutional neural networks. So it's interesting. So we just heard before, and it's very similar what I'm going to tell you is, currently, a lot of the AI computing is done in the cloud. So you have an IoT device somewhere on the edge, but then usually you transfer the raw data through a gateway to the cloud, then you do the processing in the cloud, and then you send it back. So this works for some applications, but some of the issues you have with this approach is that you need a lot of power consumption, a lot of internet bandwidth, so you always need an internet connection, and you need a lot of extensive computation in the cloud. But then also there's a privacy issue because you're sending all your data over to the cloud. And then also one of the biggest issues is the latency. So that's why you've heard that before, and you will hear it a lot today, is why more and more some of the AI processing of the inference is moved to the edge. So that is for applications then where you don't have any internet connection, or you have much less bandwidth, you need much less processing power in the cloud. And this is, I think, where we at ST come in with our microcontrollers, which are compared to some of the GPUs, processors, specific accelerators, doesn't really have a lot of processing powers, but still allows you to run some of the machine learning algorithms and neural networks in the cloud. And so what we came up with, what we're doing is called the STM32 Cube.AI. So first of all, I'll give you an overview. I don't know if any of you guys know our STM32 microcontroller family. So we have about 1,000 different parts using different Cortex-M cores from M0 up to M7. And the STM32 Cube is our software development tool, which allows users to develop usually their standard software, run their initialization and everything. And so what we've came up with is the STM32 Cube.AI, which allows you to import trained neural networks and convert them into microcontroller code and run the inference directly on the microcontroller on the STM32 at the edge. So here again is an overview of what I just talked about. So you're going from the cloud approach with high bandwidth, high centralized processing power, high latency. You're going to the more distributed AI approach, which reduces your bandwidth, lowers the centralized computing power, and gives you more real-time response, and also improves your privacy. So now I want to go a little bit more in detail. How are we bringing neural networks onto microcontroller, onto devices with restricted hardware capabilities? And so this is very interesting. It's somewhat similar to what we've just heard from Microsoft. So there's key steps how you bring neural networks onto a device on the edge. And as you can see here, the steps 1 to 3, those are the steps really which are very intensive, which you usually run on the clouds. And this is also very important. So those steps you do with your frameworks, with TensorFlow, Caffe, Onyx, and so on. And you train your model. And that's where you have like the data scientists and running all those computations. And then once you have your trained neural network, then you come to step 4, which involves the Cube.AI, which then gives you the capability to import this code, which can be written, can be generated with different kind of frameworks. We have many different options, and then converts this into microcontroller code, which then allows you in step 5 to run the inference at the edge on a microcontroller, very resource-constrained device. So the important thing is also what we heard before, is that you don't really do any actual learning on the edge device on the microcontroller. So you run the pre-trained model, you run the inference on the microcontroller, but then what could happen is, so you could collect during the runtime additional data, send this back to the cloud, retrain your model, and then deploy it through over-the-air upgrade back to the microcontroller. So this is also a summary that, yeah, most MCUs, we do not have the memory and processing power to run complex algorithms and deep learning. But for very specific applications and with the optimized code, it is possible, and it is possible also to really run the inference directly on the microcontroller, which are optimized for our tool. So as a summary again, so pre-trained neural networks, which can be generated with Caffe, Keras, Lasagne, TensorFlow, TensorFlow Lite, and Onyx, and you can import them directly into our tool and then convert them into microcontroller code. The code is optimized for the STM32 and adapts the different memory capabilities you have on the different devices. And also what is very important part of our tool is when you import the code and you get a inference with a certain size, then it automatically tells you, okay, this only fits on those devices with those hardware capabilities, and then you can decide to do some optimizations in order if you want to run it on a smaller device. So besides the STM32 Cube.AI, there's also a few other tools which we created, which allow you to implement neural networks on our STM32 microcontrollers. So we have hardware, we have some of our evaluation and development boards where you can capture the data. We have a phone app which allows you to clean, label the data. Then we have the Cube.AI, which converts your neural network into code. And then also in the tool, we have different validation and evaluation capabilities to allow you to kind of finalize and validate your model and make improvements. In addition to that, we have a lot of software examples. So we have different hardware supported. We have the software examples, which we call function packs. We have a community which allow you to pose different questions. And we have a dedicated forums for AI and machine learning. We do trainings, hands-on training, but also webinars. And then very important, because a lot of the customers which we usually deal with are embedded engineers, so they don't have the knowledge and capability to create and train a model, because as we heard before, this is more something what data scientists do. So we have therefore also a partner network which can help the customers with that task. which might be a little bit intimidating for some of us, even including myself. So then, certainly, a microcontroller is not your solution for everything. So certainly, if you have an application in a car where you want to recognize whatever 50 different objects with 60 frames per second with HD resolution, certainly that's not an application which we're targeting and where a microcontroller is the perfect device. So some of the applications where we see a microcontroller fit are sensor analysis, activity recognition, fitness, wearables, but also one big field is what is called predictive maintenance, where you basically monitor a machine, the vibrations of a motor, for example, or the noise with a microphone, and then depending when you detect that something is going wrong, you use machine learning algorithms to basically then decide the next step. Okay, there's a technician which needs to come out, or something needs to be replaced. And then there are some applications out there already which are using our microcontrollers for some of those applications, like some sensors for maintenance modules, some gesture recognition for touchscreens, and so on. So then, if we go more to the medium and high-end applications, so then if you go into audio, so something which you certainly can do with a microcontroller is keyword detection, like Alexa or Siri. So the actual keyword detection you can do on the chip without internet connection with a microcontroller, but then you would need, for the real natural language processing, you would need to go to the cloud. And then also we can do some object detection, some classification, but then, as I mentioned, if you go to higher frame rates or higher resolution, that is then getting more out of the range for a microcontroller. So here is an overview again. What do we support right now? So currently we support Keras, TensorFlow Lite, TensorFlow Lite Micro, Lasagne Cafe, and I have a slide later on which will show our roadmap. So we will have another big version coming up beginning of next year, which will also support, for example, Onyx, MXNet, PyTorch, and so on. Now let's look again, where does the Cube.AI fit into the workflow for your neural network deployment. So we've heard before, so the creation, the training, and the verification of the model you do with your standard tools, usually in the cloud. But then when you have a trained model, when it comes to deployment, then you use the Cube.AI, you import the software, optimize it, and then convert it into STM32 microcontroller code. So here is a more, now for all you geeks, goes a little bit more into detail how it actually works. So the first step in the block diagram is the neural network importer. So that's where you bring in your, for example, for Keras, your H5 file. We read this, then we validate, optimize, and compress. And then during this process, we have a neural network layer library built in. And then based on this process, we take the libraries, put them all together, and generate the code to run on the microcontroller on the STM32. So as I mentioned, we have different examples and use cases already using existing hardware. So one of the form factor hardware we are using is a little board which we call the sensor tile, and probably, I don't know if you can see it, so this is this little thing, and it's actually only like 1/2 inch by 1/2 inch, a little board, which has a lot of stuff on it. It has one of our STM32 L4 microcontrollers with the Cortex-M4 core, has a microphone, has a Bluetooth Low Energy radio, and has a 9-axis motion sensor. And with this device that gives you a lot of sensor, allows you already to run some applications, some neural networks and AI applications. Then we have a newer version of this tool, which includes some newer sensors, a more beefier microcontroller, our STM32 L4+, with 120 megahertz, more flash, 2 megabyte of flash, 768 kilobyte of RAM. So this is also supported fully by our tool, and it's also IoT ready, for example, for the Microsoft Azure Cloud and also AWS. Then another board we have, which is more targeted towards connectivity, so is our IoT node, which in addition to the microcontroller and the sensors has more connectivity, so has a sub-gigahertz radio, Wi-Fi radio, as well as NFC tag. So this is also a board which gives you a little bit more capabilities for some of your applications. And then also in addition to that, ST recently came out with a new motion sensor, the LSM6DSOX, which in addition to the 6-axis sensor also has a machine learning state machine on, which can be programmed with some of the low-level algorithms. So, and the way the architecture would work together with an STM32, so you would detect, you would put the STM32 into sleep for extreme low power consumption, just run the sensor with the machine learning algorithm, and then when you detect a certain event, then you would, the sensor would say, okay, now I'm waking up the STM32 and run some further machine learning AI algorithms on the STM32. So, and we're working very closely together with the sensor to embed it also within the workflow of the Cube.AI. So that was the hardware. So then another thing what I must mention before is also our software packages, which we call function packs, and we have different available. So one is the sensing function pack, and one example is human activity recognition. So I have this example here. Let's see if it works. So we're using, again, the sensor tile, and then we have an app on the phone which detects 5 different states, so standing, walking, running, in a car, and on a bike. So now, as the board is on the table, it shows you that I'm stationary, and now, hopefully, okay, so now, I don't know if everybody can see it, now it shows you that I am walking. No. And now I'm not running across the stage, I'm just simulating it. Now you see that I'm running. So this is a very simple example where we have the full package available with some example models which can be downloaded for free and can get you started right away with your machine learning AI project. Then here's some example, and just to give you an idea in terms of what kind of performance do you need for that. In terms of memory, so you only need 2 kilobyte of RAM, 12 kilobyte of flash, which probably in these days for GPUs or big microprocessors is nothing. So this can even run on some of our smallest STM32s. And in the example, what we've done here, so some of the important thing is, so you only need about 1 megahertz to run all those algorithms for one detection per second, and that allows you to run the whole application with less than 1 milliamp. So this is really very interesting for battery-operated wearable applications. Then another function pack we have is some image classification. So what we're using here, we're using some of our higher-end STM32s with the M7 core. We have a camera module, and then this allows you to, the example is food detection. So we have classified 18 different types of food, like pizza, cappuccino, and so on. And then we take the picture from the camera, do some pre-processing, reduce the resolution. So it's a VGA camera, but you only need 224 by 224 pixels. And then you run the neural network, which is based on FD mobile net. and then detect what kind of food it is. Also, I think the presentation about the robocars was talking about a company called, was talking about OpenMV. So this function pack also works with the OpenMV board, which is using the STM32H7 and the camera. Also, to give you an example here, I don't have it on this slide, but in terms of performance, so for this vision example, you need about 200 kilobyte of RAM, 200 kilobyte of flash, and if you run the product at 400 megahertz, you get to about 5 to 6 frames per second for the food detection, which for the application use case for food detection, which could be a microwave or an oven or something like that, is more than enough. Then in terms of where do we go from here, what are we doing to improve the capabilities of our tool? So over the time, so we introduced the product earlier this year at CES, and then we did already some improvements. Originally, we were only supporting floating point. Now we're supporting also fixed point quantization. We also support TensorFlow Lite, TensorFlow for microcontrollers. Those were all the improvements we added mid of this year. And then the next big step will be early next year, probably just after CES. We will add the full Onyx support for MXNet, Chain or PyTorch, and so on. Additional layers and also some improvements for the user interface. And then also you see on the bottom in terms of hardware, so we're supporting the different ST hardware boards like the sensor tile, the IoT node sensor tile box, our H7 discovery kits, but then as I mentioned before, we're also supporting the OpenMV H7 cam board as well. So again, to summarize, so all the solutions for bringing the machine learning AI to the edge with an STM32, they center around the STM32 Cube.AI, which is the software tools, but also we provide the whole system. We provide the function packs, the hardware, the community, the partners, and the phone application. And so here, if you want to know more about it, so you go to st.com/STM32Cube.AI or take a picture of the QR code, and you can find out more details. And again, to stress, all those tools, the function packs and so on, can be downloaded free of charge from our website. Okay, thank you very much.